The Lakehouse is sort of a modular setup where you decouple the storage and the compute. And that has a lot of benefits, but that also means that you're going to have to make several choices. I think it really starts at the storage layer, and that's where you're going to store your files. So that can be either on the cloud or on-prem. And when you're on the cloud, you're typically on something like S3. If you're on AWS or Azure Data Lake Storage, if you're in the Microsoft ecosystem. So for me, I'm an Azure guy, so it's typically Azure Data Lake Storage. So when you have that as a given, then the next step is indeed to choose a table format. And there are really three big ones out there. And there's kind of a religious war ongoing between different people, which one is the best. I will not go join that war. But the most popular ones are Delta, Delta Lake, Iceberg, and Apache Hoodie. I'm most familiar with Delta Lake. The most important thing is that you choose one of those. And all of those table formats have the same underlying file format, which is Apache Parquet.
Hey buddy, welcome back to another episode of How AI is Built. Today we have a very special guest. Jorrit Sandbrink is an experienced data engineer and architect specializing in Lakehouses. We discuss the advantages of open source solutions for Lakehouses orchestration and data ingress, discover tools like Delta Lake, Polars, Dexter, and DLT, and learn how they can improve your data operations.
A lakehouse is an architecture for data analytics platforms. And the word itself is really a blend of two other words. So if you have a data warehouse and a data lake, you can combine the two and you get a data lakehouse. And the term, it got introduced in a white paper a couple of years ago, back in 2021, was a white paper by the founders or some of the founders of Databricks. And they introduced the lakehouse architecture. And really what it tries to do is it tries to address some of the shortcomings of the data warehouse and of the data lake by combining the best of those paradigms into one architecture. So you don't need two platforms and you can really have just one for all your workloads.
Yeah. And can you tell me a little bit of a story? Like, how did you get into it? And what was the problem you wanted to solve when you really first started considering setting up a data lakehouse?
Yeah, so it's not really that I had a problem and that the lakehouse came as a solution. It was more like me entering into an organization, into a very big team, and they were setting up a lakehouse platform. So we had a very smart architect there. He was, let's say, ahead of the game. The lakehouse was still very new back in 2022, that was. And yeah, like I said, I kind of rolled into it. We were setting up a lakehouse platform and I learned about it back then. And I really loved it ever since because I think the elegance of the solution is very nice.
Yeah. And looking at the data lakehouse, there are like a bunch of decisions I think you can take if you're looking at basically the file formats you choose for storage, how you partition the data, but also what table format you're using, and then in the end also what query execution engine. Can you walk us through the different options, starting especially at the file format when you insert the data?
Yeah, sure. Totally correct, because the lakehouse is sort of a modular setup where you decouple the storage and the compute. And that has a lot of benefits, but that also means that you're going to have to make several choices. I think it really starts at the storage layer, and that's where you're going to store your files. So that can be either on the cloud or on-prem. And when you're on the cloud, you're typically on something like S3. If you're on AWS or Azure Data Lake Storage, if you're in the Microsoft ecosystem. So for me, I'm an Azure guy, so it's typically Azure Data Lake Storage. So when you have that as a given, then the next step is indeed to choose a table format. And there are really three big ones out there. And there's kind of a religious war ongoing between different people, which one is the best. I will not go join that war. But the most popular ones are Delta, Delta Lake, Iceberg, and Apache Hoodie. I'm most familiar with Delta Lake. The most important thing is that you choose one of those, and all of those table formats have the same underlying file format, which is Apache Parquet. So it's really important to make the distinction here between a file format and a table format. So the file format is really the raw storage container where you have the actual data. And like I said, that's typically Apache Parquet. It's been around for a long time. It's very mature. And then later came the table formats that added an additional metadata layer on top of those file formats. And really what that metadata layer is for is to introduce some data management features that are very needed, that are related to data quality, that are related to asset transactions. And those table formats are really what enable the lakehouse. So if you have your table format, then I think the last component to complete your lakehouse would be a query engine, right? You decouple your storage and your compute. So you have something for your storage. Now you need something for your compute. There are a lot of options here. One of the most typical ones is Apache Spark. So Apache Spark, you can use to read your Delta tables, for example. And then in essence, you have your lakehouse.
Is Spark required as a query engine, or can I just purely use something like Polars, which is basically a data frame alternative to Pandas, to query my Delta tables as well?
Yeah, definitely. And this is also a shift I'm seeing, or a trend in the data industry. So it all started out with Apache Spark. Again, that's a very mature system. It works, it does the job, but it isn't always best suited if you're working with something that's not big data. Like if you have small to mid-sized data, then a distributed system like Apache Spark might be overkill. There's a lot of overhead. So it's really nice to see that in the latest years, we have some new compute engines entering the systems, Polars being one of them, which is much more lightweight. It can run on a single machine. It's super fast. And it also has support for the Delta Lake table format. So that means you can now have a lakehouse without using Apache Spark, which is super fast, lightweight, and much more easy to maintain and set up.
And this is especially relevant if you like compare basically when I can run my computations on a single node, I'm better off actually going with Polars or DuckDB, which allows me to actually keep it on one node rather than distributing the computation in a complete Spark cluster, especially when I'm looking also at the development effort, which is going into like the different technologies.
Yeah, totally. So again, if you have a lot of data, then you want the distribution. But if you don't have that, then there are a lot of downsides to managing something like Spark. It can be a good one size fits all solution. So I have worked in different organizations that use Spark for the lakehouse, does the job. But I think right now, looking forward, there are a lot of chances you can use basically with something like Polars.
Yeah. And you already mentioned a little bit the management side of it. Is there anything to consider in the lakehouse where I have to take active steps for some recomputation, some partitioning, or some active management with the actually file storage or with the metadata layer?
Yeah, so going from a file format like Parquet to a table format like Delta, it took away a lot of that. So before you really had to manage your files at the file level, which was kind of cumbersome. So the table format allowed you to, yeah, it added a table abstraction on top of those files. So now you can reason about tables instead, like you were used to in a good old database. So that made it easier, but I'm not going to say that you can completely forget about what the data lakes looks like. You're still going to have to think about how you can optimize the layout of your files, of your tables. Now, there are also ongoing efforts there that simplify it, that do it for you. For example, if you're on a platform like Databricks, they can do a lot of auto optimization for you. And they really want you to forget about the data lake and never look into the raw files. I think as a data engineer, it's still good if you have somewhat of a deeper understanding of what it looks like, because in some cases, you're really going to have to think about what is the optimal file size. For example, the file size has to do with the performance of your queries. And sometimes that doesn't automatically go right. And then you have to take a step to intervene and run something like an optimize command, which will take all your files and rewrite them into a more suited file size, for example.
Is there also additional steps in, for example, for partitioning? So if I, for example, partition my data by date on which is collected, which would give me more or an improved performance on a lakehouse for query?
Yeah, totally. And that's also what I used to do a lot in my previous project, or what we used to do a lot, I should say, where we had what is called a functional data engineering paradigm. So basically, we had new snapshots coming in every day, and we would just create a new date partition for that snapshot. We would keep the old partitions and just add a new one. And the nice thing about it is that when you're going to query that data and you have in your where clause a filtering on that date, you can only open the directory belonging to that date in your data lake, which is very efficient. There's a lot of data skipping going on there. So partitioning is definitely still a thing that you want to do. Again, there are ongoing efforts to abstract this away. There is a thing called liquid clustering in Delta. Yeah, supersedes the partitioning strategies, but this is still fairly new. I think in many organizations, partitioning is a thing that is done and that is very useful.
So basically, just to make it a little bit more concrete, when I'm talking about partitioning, I basically could select a certain folder within my data lake and then just execute the SQL query or whatever I'm using in the end on that partition to do like additional filtering or selection of the relevant data.
That is correct. So what you can do is when you create your table, you have a simple create table SQL statement as you're used to in a database. You can also add a partitioning there on the table, and that's going to make sure that that data is going to land in different directories in your data lake. And then in a later phase, when you're going to query that data, you want to read it again with a SQL query, you simply add a where clause to your select from, and then you have something like where date equals the 23rd of February, and then it's only going to take that folder, which is very efficient.
Are there any additional optimizations, especially in configurations you've seen on data lakes, which optimize it even further for a lakehouse setup?
There are many things you can do. We're talking about partitioning. You can also have multiple layers of partitioning. But I think the trend right now is that you really give it over to the query engine, the engine that writes. I'm talking about the writing process now. So you sort of let all those optimizations be done by a smart write engine instead of you trying to configure it with settings. Again, if I'm thinking about Databricks, they're doing a lot of auto optimization for you, and they can do a lot of smart things behind the scenes that should lead to optimal layout of your data. For example, there is this thing where you group similar data, where you co-locate similar data in the same files. So typically when you do a query, you are querying certain data that is related to each other. And when that data is in the same file, that is very efficient. You can just open that file and disregard all the other files that don't contain the data that you're not interested in.
And looking at the bigger database market, because the alternatives to a lakehouse seem to be like rather document storage, so MongoDB, Elastic, how do they compare to the data lakehouse? And would you go with a document store over the lakehouse, and the other way around? When would you choose a lakehouse over a document store?
Yeah, I think it has to do with use cases. So I think the lakehouse nowadays is really the number one choice if you're doing analytics, maybe more specifically if you're doing batch analytics. And then if you have very specific other use cases, I don't know, maybe you're doing streaming, and you have a very high performance streaming use case. Perhaps the lakehouse is not the right architecture for you. Or maybe document stores. I don't know if you're doing something that has to do with logs. You want to search through logs. Maybe there are more specific solutions that are optimized for that. And the lakehouse might not be the best choice for you. But in general, if you're doing batch analytics, I think the lakehouse is really the superior architecture nowadays.
And now moving on, it's like more of the query execution. You had a nice blog post, especially comparing DuckDB and Polars. How do DuckDB and Polars compare, and which one is your current preference for your work?
So DuckDB and Polars share a lot of similarities. They're both single node compute engines, and they're both new players in the game, and they're both super fast. So that's very cool. DuckDB is coming at it more from the SQL database side. So really what they looked at was the SQLite database. They took a lot of their principles and built a new analytics compute engine on top of it. And then if you compare that with Polars, which takes more of a data frame approach, it's not a full database, it's just a compute engine, and it has a data frame API similar to something like Pandas, maybe. So I guess if you want more of a SQL kind of experience, DuckDB would be your choice. If you want more of a Pandas experience, you would go for Polars.
So it's not really a use case consideration, but rather your preference in the end or what you're used to, because it seems really like the Polars is really suited for data scientists and data analysts as well, whereas DuckDB is rather for the data engineer who are used to doing most of their stuff in SQL.
Yeah, I think that's correct. So if you're a data scientist, you will feel more natural in Polars. And if you're an old DBA, then maybe you would feel more comfortable in DuckDB. There are some differences when you look at the storage format. So DuckDB has their own native storage format, which is coupled with their compute engine. They are adding support for reading stuff like Iceberg, and maybe Delta is also common, but that's still in the works, let's say. Whereas if you look at Polars, has very good support for reading Delta tables. So if you're thinking about a lakehouse architecture, I guess Polars would now have preference over DuckDB.
Yeah, what would be my option if I decide to go with DuckDB? How could I basically convert the data I have in my lakehouse and insert it into the DuckDB where I do my processing?
I don't really know if that is an option nowadays. I think you can read Iceberg tables with DuckDB, but the support is still rather limited. Now, I think a lot of things are happening in the space, so this could move very fast. But nowadays, it might be a little bit difficult to operate a full lakehouse on DuckDB.
Yeah, we have already touched a little bit on especially the batch processes where the lakehouse seems to be like the data format which is most suited. How do you go about especially triggering the executions and where do you deploy those? So are you going for more of a serverless architecture on top of a lakehouse or more of a like cluster, a Kubernetes cluster? And what are the common libraries you use for that? So are you still using Airflow or are you going rather to the more modern tools like Prefect or Dexter on top of a lakehouse?
Yeah, so we're talking orchestration now. Orchestration is something I looked quite deep into in my last project. And what I ended up doing there was building a custom orchestration framework. It's not definitely something I recommend in general. I would say take something off the shelf if you can. There are very good open source orchestration frameworks out there. You mentioned some of them, Airflow. So let's say the incumbent, a very established, mature solution. And you got some new players, I think most notably Dexter and maybe also Prefect. So when I would set up a new data platform, I would typically go as much open source as possible. I think that would be one principle, and also go as lightweight as possible. So really, if I had to design a new platform from scratch, I would look at something like Dexter. Dexter is addressing a lot of issues that Airflow had, or maybe not issues, let's say learnings, new insights after many years of running the thing in production. And it's taken some alternative design steps, which makes it quite an elegant solution for orchestration nowadays.
Yeah. And what are the major components of the different orchestration tools? What I'm often looking at is like rather the source, the trigger, operations, and then the target. So where is the data going? Is this a good level of abstraction or do you have additional components which I didn't consider?
No. So let's say the trigger is very essential. The trigger in many cases is a cron schedule. Just trigger this pipeline every day or trigger it every week or maybe every hour. I don't know. If you want to go a little bit more fancy, maybe you have something that's more event driven. So let's say whenever a file lands in my data lake, I want to kick off this process. So that would be the trigger side. But then indeed, you're going to have to process some data typically, which means you're going to have a connection with where your data lives and also where you're going to write it to, right? So your orchestrator needs to support those things. Let's say if I want to write it to Snowflake, then I should be able to have a connection to Snowflake to write my data there.
Yeah. And how can I imagine it working below the hood? So I have the source, the DAG was triggered. I extract my data, and then I have multiple processing steps most of the time. So they might be SQL statements, they might be Python scripts. How are they hosted, and how are they actually also scaled if I have massive batch workload or I have multiple batch workloads coming in at the same time?
Yeah, so that's more on the infra side, which is a whole, let's say, profession in and of itself. I think if you look at something like Airflow, you typically run it on a Kubernetes cluster. So in my last organization, towards the end, we were looking at Airflow to move the custom orchestration framework I wrote, transfer it to Airflow. And indeed, what the infra guys were doing is they were setting up Airflow on a Kubernetes cluster where you have a lot of control over things like scaling, because in the end, your processes are running on the pods of a Kubernetes cluster. And if you run a lot of processes, then yeah, your cluster is going to have to accommodate for that. That is not a specific orchestration or data engineering consideration, I would say. That's more of an infrastructure setup consideration. But yeah, you definitely have to take that into consideration, especially when you're scaling out to many data pipelines.
And you recently also started working on DLT or consulting on DLT, which is rather a data ingress tool, how they call themselves. How would you differentiate like the data orchestration and the data ingress tool? Because in DLT, you also have like much of the same components as in data orchestration. So you have sources, you have targets, you have transformations you're doing.
Yeah, that's correct. I started working on the project DLT, an open source project. I'm quite passionate about it. I think if you look at how DLT describes themselves, it's not necessarily an Ingress tool, but it's a tool to build data pipelines. But yeah, there is a high focus on the first stage of the data engineering lifecycle, which is ingestion. So you want to take your data from your source systems and you want to ingest it into your data warehouse or into your data lakehouse. And what DLT does is make that process easy. So you can declare your pipelines in a declarative way. You can basically say, okay, I have my Postgres here. These are the credentials. I have my Snowflake here. Please transfer over these tables, right? So that's the extract and the load in a typical ELT process. Now, if you compare it with orchestration, is you can build your pipeline in DLT, but you're still going to have to trigger it somehow. And that's where the orchestrator would come in. The orchestrator orchestrates and the pipeline processes data. I think that's how you can offset the two.
Yeah. And what are the common issues that DLT is solving, especially when I'm looking at the competitors like, for example, Fivetran or Airbyte?
Yeah, so they're really in the same space, and that would be the space of extract and load. Again, the first stage of the life cycle. But you really have a choice here. So Fivetran is the incumbent. It's a proprietary solution, which probably is very easy to use. I've never used it, but I can imagine it has a very fancy user interface and it just works. But maybe it's a little bit expensive. And then you have, let's say, the open source alternative to Fivetran, which would be Airbyte, which also has a nice user interface, but you can run it yourself, which might be cheaper in the end. But both of those solutions, they are platforms. And where DLT really takes a different approach is that it's explicitly not a platform. It's a library, Python library in this case, which makes it much more lightweight and which also allows you to basically run it everywhere. So you can run DLT in a serverless cloud function, which is quite nice if you have that use case, and makes it very easy to install. You can just pip install DLT and you're good to go. So it's a little bit more tailored towards the engineer and less towards someone that's less tech savvy. You're going to need some engineering skills to work with it. But if you're an engineer, it's really enjoyable to use it.
And especially the combination with serverless functions, DLT for me really shines, because often when I'm looking at data collection, I cannot really predict in advance how much data is coming in to the serverless endpoint. So I'm restricted with how I can actually scale the memory. And DLT especially has one feature, which is why I chose it in the end, which is writing to disk and being really memory efficient by using generators, especially.
Yeah, that's correct. If you're starting out, like you say, you often don't know how much data you're going to have, and you just want to start up fast and lightweight.
I
think DLT can really come in handy in those cases.
If you wouldn't have a specific use case or you wouldn't have the details, what would be your default tech stack for orchestration, data collection and ingress, data processing, and data storage?
So I think I already mentioned some of the principles that I try to follow, which would be as much open source as possible and as lightweight as possible. So looking at storage first, the table format, I would go for Delta just because I'm familiar with that. It's a very mature project. It's backed by some big companies, Databricks, and Microsoft has also embraced it. So I think that's a safe choice. Then looking at the compute engine, I would really try to work with Polars because of the benefits we mentioned. It's very lightweight. It's super fast. It has a data frame API. I'm a Python guy, so I prefer Python over SQL. Then going to orchestration, I would try to use Dexter. Dexter is an elegant solution. It has a lot of support in the community as well. And it's some of the shortcomings of Airflow. And then for extract and load, what else can I say than DLT? I'm a bit biased here, I will admit, but DLT is also an elegant solution. So that would be my open source data stack if I had to design it right now.
And next to it, what would you love to see being built in a data space which would complement your stack as you build it right now?
It would be a very specific thing. So right now I'm developing for DLT and we have to do a lot of type mapping there. So data types are different or a little bit different in every system, which can be a pain in the ass if you have to map a type from one system to the other. So really what I want to see is an open source library that has all these mappings in place. Something like SQLglot. I'm not sure if you're familiar. SQLglot is a very nice Python library that can transpile between different SQL dialects. I was thinking the other day, it would be nice if there were something like typeglot that you could just install, which can do all of your type mappings. Maybe it exists out there. If it does, please let me know. But that's what I would love to see built in the data space.
Great. So what's next for you in the data space? What do you want to learn next? Where are you going next?
So right now I'm enjoying contributing to DLT a lot. In general, I would love to continue working on data tooling rather than building data platforms and using the tooling. So it would be a shift from data engineering towards software engineering. But I would love to keep operating really at the combination of those two fields. I love data engineering. I love software engineering. If I can keep doing that, I'm a happy man.
Great. So where can people follow along with you, your work, what you're doing in your day-to-day?
Yeah, so my LinkedIn profile, I think, is the best place. I post some content there every now and then. If you want to get in touch, send me a message.